In this next example, we'll be looking at a problem that involves a truck that's starting out carrying a crate, traveling at 80 kilometers per hour, and somehow that crate works its way off the back of the truck, falls onto the ground, and because of friction begins to decelerate and eventually come to a stop. In the problem statement, it tells us we know the distance it travels, determine the coefficient of friction. And so, looking at the problem statement briefly, pause it if you'd like to copy it. We have a mass of 60 kilograms, initial velocity of 80 kilometers per hour. It travels 45 meters on the ground, and we want to find the value of the static coefficient of friction. And so we write a free body diagram, which shows all of the forces acting on the block only. That's all that we care about. We have a coordinate system showing the definition of positive. And so we're going to be able to write equations, sum of forces in the x, sum of forces in the y. Now, of course, I didn't do the state diagram. I did it in class. This is a two-state problem. Block is traveling, then finally block comes to a stop. Friction is the only force acting. It is a constant force, therefore accelerations are constant. So we're going to be able to use constant acceleration once we determine or we're going to use constant acceleration to help us relate distance traveled to the acceleration of the block. Alright, so sum of forces in the y on this thing is simply going to tell us that the normal force is equal to gravity. So sum of forces in the y equals 0 because there's no motion in the y. Normal force minus the weight, mg, is equal to 0. And so here's our normal force of 588.6 newtons. Sum of forces in the x only involves the friction force acting in the negative direction. So minus mu n is equal to 60 times the acceleration in the x direction. Solving this for acceleration in the x direction, it's going to be a minus mu k n divided by the 60. But n is equal to 60 times 9.81. So the 60s are going to cancel, and we'll be left with ax is equal to minus 9.81 times our kinetic coefficient of friction, which is now unknown. We could have done this one at any point because it's a one equation, one unknown thing, and that is v squared final is equal to the starting velocity plus 2 times the acceleration times the distance traveled. That's the ADS form of ADS equal VdV form of constant acceleration. So our stopping velocity is 0. Our starting velocity was 80 kilometers per hour, converting that into meters per second squared, plus 2 times the acceleration times the distance we traveled. The acceleration is the only unknown in this equation, and so our acceleration comes out to be a deceleration, as expected, of negative 5.5 roughly meters per second squared. And going to taking that acceleration and plugging it into our sum of forces in the x equation. We know the acceleration now. The only unknown is coefficient of friction. And we get a coefficient of friction of 0.559. Now, that's a pretty high coefficient of friction. I suppose it depends on the surface of the road and the kind of wood and other things. That's still a fairly high coefficient of friction. But there is the answer.